In this video, I'm going to conduct both simple linear regression and multiple linear regression on my Major League Baseball data. So in my previous video, what I did is I transformed the game level data into team performance. So now I can be able to, with that, I can conduct different forms of analysis on team performance across different seasons. So to get started, I'm going to set my working directory and then load load two libraries. First, tidyverse to support some data manipulation and ggplot. And then I'm going to also load leaps. That's a library that's going to support my subset selection methodology that I'm going to be using for multiple linear regression. All right, so next I'm going to start off with descriptive analytics. So I'm going to respond to a question of what is the overall winning percentage for the Twins compared to other Major League Baseball teams. So what I'm going to do is I have team level performance for each season, but what I want to do is I want to look at what's their combined performance across all seasons that I have in my data. So again, that's from 1960 to 2022. I want to add all that data together for each team, and so I'm grouping it by team across all seasons. And I'm going to then put that aggregated data into a new data frame called team wins. So I'm going to go ahead and create that, and then when I take a look at my team wins, I can see the total number of wins and the total number of losses across that time frame. Again, 1960 to 2022, and I have that for each teams. Now you'll note that there's not 39 teams in Major League Baseball, but between different locations, so we have also some teams that are no longer in existence, plus all the teams that are in existence or teams that have moved, that comes up to a total of 39 teams. And so that's why the number's different than what you would expect. All right, so now I have that data aggregated. So I have the total wins and losses for each team during that time frame. But what I want to do is I want to come up with a winning percentage, because I think that's going to be, since not all teams have played the same number of games, we really can't look at wins or losses, but rather a percentage of the games that they've played. What is the percentage of the games that they won? So what I'm going to do is I'm going to take the total number of wins for each team, divide that by total number of wins plus the total number of losses, in other words, games played, and do that division, and then round it off to 3 decimal places, and that's what I'm going to report at this house. I'm not going to report this as a percentage, but a decimal percentage. So when I Control Enter to create that field, that column in my team wins data frame, now when I open that up, I can see I have that 4th column now, which is my winning percentage for each of the teams in that data frame. All right, so now with that data, now I can go ahead and plot this. I'm going to create a bar plot, but this is going to be rather than a vertical bar plot, it's going to be a horizontal bar plot showing the winning percentages for all Major League Baseball teams from 1960 to 2022. And I'm also going to have labels for my x-axis and my y-axis. So Control Enter, and here is my my bar plot. You can see it's a horizontal versus a vertical bar plot. Since I have so many columns of data, it's better to do this coordinate flip so that I can see this as a horizontal bar chart. And I have all the data is also labeled for each of the bars so that I can look at each team and how they performed during that time period, and then I can see the Minnesota Twins are in the upper half of that of Major League Baseball for wins during that time period. All right, now back over to my code. Next, I'm going to do a diagnostic analysis. I'm going to respond to the question, how have the Twins' winning percentage changed over the years? So here I'm going to, again, looking at the winning percentage, I'm going to go back to my team seasons data frame and create that winning percentage in that data frame as well. So I created winning percentage in that new data frame I created for to be able to look at all performance across all that entire time period. Now I'm going to go back to my team seasons data frame and create the winning percentage there. Again, it's the same calculation, total number of wins divided by games played, and rounding that off to 3 decimal places. So I Control Enter, and then I can go to my team seasons. There's 63 variables now, and if I go to the end of that, I can see that I have my winning percentage. So total wins, total losses, and what that winning percentage looks like. All right, so now what I'm going to do is I'm going to do a plot. This will be a scatter plot. I'm going to take a look at the Minnesota, actually it's going to be a line plot. I'm going to be looking at the Minnesota Twins winning percentage across each of the years, from 1961 when they first formed all the way to 2022. So when I Control Enter, I can see here, actually I'm going to zoom in on this, click on Zoom, and then I'm going to maximize this. So now I can see from 1961, their first season, all the way to 2022, I can see their winning percentage. Now, I could zoom in on this, but I chose to keep my y-axis the full percentage from 0 to 100%. This way, we can see that they fall somewhere in the middle, and we can see how far or below they were above 500 each of the years. There are many years that they were below 500, and there are also many years that they were above 500. But we can see how that has changed over time, and there's not a general trend one direction or the other. But this plot then helps us respond to that question of how the winning percentage has changed over the years. All right, so next I want to do some exploration to get ready for a predictive analysis. So I want to look at that winning percentage of looking at the variables that contribute to a team's winning percentage in a given season. So this will be season level winning percentage, and look at what attributes of the season of the team's performance perhaps contributes to their winning percentage. And I'm going to first look at looking at the number of runs. So the number of runs that they scored in a season, if we have more runs in a season, or do they have a higher winning percentage? And we're going to simply look at a bar chart for this. So runs versus winning percentage. So when I do that, and I'm going to zoom in again and maximize this, and we can see, so these are the different seasons, and right here we can see the number of runs scored. So first what we're doing is before we compare them, we're just seeing what we're going to, if we see that there's a fluctuation, or if there's a trend, and we see that there's really not an overall trend up or down. It goes up and down each season. So that's what the data looks like here. All right, so now let's go back to our code. And we're going to also look at how the number of singles have changed over time. So again, across the 1961 to 2022, the number of singles that they hit over for each year. And we're going to, again, this will be another bar chart. We'll do this in orange this time. And Control Enter. I'm going to zoom in on this. And we can see, similar to hits, we can see the runs scored have also changed over time, but again, no up or downward trend. All right, next we're going to take a look at another bar chart. We're going to look at scoring differential. So the number of runs that they scored versus the number of runs that the opponent scored. And so this is going to look a little different because sometimes the Twins have given up more runs than they've scored over a season. So that's why we're going to have values that are above 0 and below 0. And you can see there are periods of time, several seasons in a row, where they're giving up more runs than they've scored. Early on, they were scoring more runs than they've given up. And more recently, mostly they had a really good season back in 2020, where they had scored a record number of 185 runs. But we can see that does change over time. All right, and then finally going to look at number of strikeouts. So this is not the number of times that they've struck out, that the Twins have struck out, but rather the number of pitch strikeouts, how many times our pitchers have caused the opposing team to strike out. And here we go, taking a look at here. And again, this is from 1961 to 2022, and we can see how that's changed over time. Not as variable as we've seen in other measures, but we can see how that has changed. And again, 2020, that was a good year for the Twins. That they, while they scored a lot, they did not strike out other teams very often. So that's an interesting combination there. All right, so now what we're going to do is we're going to get ready to do our predictive analytics. And we're going to be doing linear regression. So what we're going to do is we're going to begin by splitting the data. I'm going to randomly assign 75% to training data, 25% of our data to testing data. And again, the data is going to be the team seasons data. So I set my seed to 1 so that I can reproduce this if I need to. And then I set my sample, and I assign data to the training and to the test, and then remove my sample list. So now I have the data spread across training and testing. Now with that, I'm going to go ahead and start my linear regression model. So what I'm going to do is I'm going to use that training data to develop my simple linear regression. So let's take a look at the variable that I chose. I'm going to take a look at the number of runs and the winning percentage. So the winning percentage is my dependent variable. The number of runs is my independent variable. So I'm going to have a winning percentage as my y-axis and runs as my x-axis. And this will be a scatter plot. Let's take a look at what this looks like. All right, and I did use that linear model to show what the model would look like, where I try to create a linear relationship between the two. And there's maybe somewhat of a linear relationship, not very clear. There's a lot of variation from that. But this is what the runs versus winning percentage for all this. So again, I have one dot for each team in Major League Baseball, not just the Twins, but each team for each season. All right, so now let's take a look at the results for this. So if I summarize this as into a model, so I'm going to conduct a simple linear regression on the data and see what that looks like. And down here, I can see the results of this. So it shows me my y-intercept and my slope. So then I could see what the equation looks like, and it also shows me the r-squared, the p-value. So here is all the output that I can use to evaluate the fit of that model to my data. All right, now we can see that wasn't a great model. It somewhat linear relationship, but let's take a look at a data set or another variable that's going to probably fit better. So if I take a look at the run differential, that means the number of runs that the team scored versus compared to the number of runs that they gave up in a season. So if they scored more runs than they gave up, you would expect that would mean that they're going to win more. So this should clearly be a linear relationship. It's somewhat cheating because you would expect that to be the case. So while that would really not give us much actionable information if this were true, we just want to see what a better fit would look like. So again, this is run differential, taking the number of runs scored in a season versus the number of runs that they gave up in a season. And run that. And here's my plot looks like. So as expected, it's a much tighter fit and clearly a linear relationship. So the better your run differential, the more runs that you scored versus gave up, the more higher your winning percentage is going to be. Again, it's not it's not expected. It's not unexpected. It is expected, and that's why we would have this stronger relationship. So this is what a good relationship looks like. All right, so let's take a look at that linear model. So I can summarize this, and here's what the results look like, and this is where I would evaluate the fit of that model. All right, so now moving on, I'm going to develop a multiple linear regression model. And I'm going to use variables of runs, hits, pitch strikeouts, and runs batted in, or RBIs. But let's take a look at what each of these looks like. I'm going to do a scatter plot for each of these variables compared to winning percentage. So first, here's runs versus winning percentage. And I'm going to zoom in on that. And you can see, as we saw before, this is somewhat of a linear relationship, but not a tight linear relationship. Next, we're going to look at number of hits, so number of singles versus their winning percentage. So zoom in on this, and I can see there doesn't look to be a very strong linear relationship whatsoever. And next, I'm going to take a look at strikeouts. So strikeouts, the number of times the team has struck out the other team, and versus their winning percentage. Zoom in on this, and this also looks like not much of a linear relationship. And then finally, I'm going to take a look at RBIs, run batted in versus winning percentage. And as I would expect, the more RBIs you have, the more often you're going to win. So there is a slight relationship, linear relationship between runs batted in and winning percentage. All right, so those are four variables that perhaps could contribute to winning percentage. So those are the variables that I'm going to use in my as candidate variables in my multiple linear regression model. So next, what I want to do is I want to create a data set, a data frame that contains only the 5 variables that I'm looking at, the winning percentage, and then those 4 variables that I decided to consider in a multiple linear regression model, and that is runs, hits, opponent strikeouts, and RBIs. So that's what I'm going to do right here. Is I'm going to take that training data frame and grab those specific columns and move them into a new data frame called train select. So train select was created, and I have the 5 variables: winning percentage, runs, hits, opponent strikeouts, and RBIs. All right, so next what I'm going to do is I'm going to then do a subset selection method to determine which of these candidate variables I should use in a multiple linear regression model. So I'm going to do this, use this function here to determine to determine which of the variables are going to be used to predict the winning percentage. I'm using my train select data frame, and I'm going to want a multiple linear regression model that's going to have a maximum of 4 variables. So these are the 4 variables that I'm looking at. So what I'm saying is, if I had more variables than that, I'm saying that my final model, I only want to use have a total of 4 variables that are going to contribute to that multiple linear regression model. So all the results, the model get output into this multiple linear regression model data frame, and then I can go ahead and summarize that. And then here's the results of that subset select method, and this would tell me what elements or variables that I want to include in a multiple linear regression model. And then I can also look more specifically at 3 different options to evaluate which model to look at, and this would give me the best model that I'm going to use. So I could use the adjusted R-squared, the CP, or the BIC methods of evaluation, and whichever I choose to use, that would tell me which variables that I would want to use. All right, so next I'm going to use all 4 variables to create a multiple linear regression model. And that's what I'm going to do right here. So I'm going to move that into the model and look at the model. And here are the results that I can take a look at that. So this is my multiple linear regression model, which is going to predict winning percentage based on runs, hits, opponent strikeouts, and RBIs. And then I can also look at the coefficients, and then the intervals. All right, so now what I can do with that model, so now I understand how good that model is, or I'll be able to evaluate that. I'm going to apply each of these models to my testing data. So the models were developed using the training data. Now with the models developed, I'm going to apply them to the testing data. So what I'm going to do is I'm going to use that simple linear model that I created earlier and apply that to my test data and take a look at what the results look like. So these are the first 10 rows, or first 10 observations. And that's my confidence intervals, and then also my predictions. And now what I can do is with that data, that helps me understand the fit. I can also visually see this. So I'm going to go ahead and plot that linear model so that I can take a look at what my predictions look like compared to what the data actually showed. My code and not the analysis in this video. So you're going to have to take a look at the results and judge for yourself. Was this a good model, or is there a lot of improvement in the model? All right, so that's how I plot the fit to be able to evaluate the linear regression from that I developed on my training data and applying it to my test data. And then I also do the similar functions for my multiple linear regression model. I can look at the confidence intervals for that and also my predictions, and then be able to plot that as well so that I can take a look at that visually to look at what that looks like. There we go. All right, and then my final step is to go ahead and clean up all the temporary data frames that I created in this analysis. Just clean that up for future work. And that's my code. So this is the code that I created to conduct both a simple linear regression model and a multiple linear regression model on my Major League Baseball data.